daily temperatures. Given an array of integers, temperatures represents the daily temperatures. Return an array answers. Alright, so I gotta return an array answers, so might as well just write out that output. Return an array answers such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. This feels very similar to another problem I did. I forget what it was called though. One of the previous units, I think it was like a 2-pointer thing. Let's see how this is different. So such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there are no future days for which this is possible, keep the answer I equals 0 instead. Okay. So example 1, temperature is 73, 74, 75, 71, 69, 72, 76, 73. So 73, 1 day, so 1. 76, 0, 73, 0. 75, 1, 2, 3, 4. I see, okay. I think I'm getting the hang of it. So 1, 1, 1. Or sorry, 1, 1, 1, and then this is 0. 1, 1, 0. Alright, cool. So temperatures, again, some basic quadratic questions, clarifying questions. What's can its size be? Can it be empty? How big can it be? It just says integers. Can those integers be negative? Like, what's the range of the integers? What are the boundaries? There's no particular order to this, so you gotta keep that in mind. Yeah, those are some clarifying questions I would have for the interviewer. Yeah, I'm the interviewee. So, okay, so length of 1 is the minimum. And temperatures, oh yeah, I guess the content. Oh yeah, I did ask that. Okay, it can't be negative, but it's 30 to 100. Cool. All right. So we already did start with like just kind of making sure that we had the right output. I like to do this at the beginning just so this doesn't get messed up later on. But yeah, I mean, just taking it that first example. And just make it big. Yeah, there we go. How I would do this on pen and paper. I'll just like start here. Right, start here. And how long does it take to get a higher temperature? Well, this is a higher temperature, right? That's what, to get a warmer temperature, yeah. So, and then we have like a corresponding array down here. And that would be 1. And what about this one? That's 1 as well. Okay, then move to this one. So not this temperature, not this temperature, not this temperature, but this temperature, and that's a total of 4 jumps. Same thing here, so 1, 2, 69, 1, 1, 0, and 0. Yeah, it ended up getting a bit messy at the end over there. So at worst case, that could be O(n) of squared time, right? If it were all non if it were in decreasing order. Yeah, worst case. And space complexity, I don't know if the answers count, but that would be ON. We need that. Like, I don't think there's a way to get rid of that. That's the way I would do pen and paper. That's brute force, I believe. Is there an optimal way to do it? Well, I mean, I know this is a stack question, so there probably is. How would I use the stack to go about doing this, though? Would this involve some two-pointer solution as well? Let's read the question again. Given an array of integers, temperatures represents the daily temperatures. Return an array answer such that the answer size is the number of days you have to wait after the ith day to get the warmer temperature. If there's no future day for which this is possible, keep answer I is equal to 0 instead. Not sure if I'll have like a whiteboard like this in an actual interview though. Not now that I'm thinking about it. But you know, we gotta do what we gotta do. Now, okay, if I were to use pointers, the reason why pointers pops up in my head is because, well, we still do need to check every element. Like, am I making an incorrect assumption when I say 73 we have to check the elements on the right, 74 we have to check, 75 we have to check, right? Like, even with the left and right pointer, like left, right, what's that gonna do though? Like, we're just gonna move right along and then break, and so it's the same kind of algorithm like before. What if we start popping things off the stack? Well, that will be good. We're mutating this, which will affect it. I guess depending on the order of the actual list, maybe we consider that. Like 69 is, well, no, 76 is the one that we know for sure won't have anything after, like any temperatures afterwards. There won't be a warmer temperature, but we know that because we took a look. Yeah, tough. I would like just kind of using the valid parentheses example. We had this opens bracket stack, I would say, right? And we would just like append. Oh, we created this like list to represent a stack, and we would append the items into here. Can we do something similar here? So, like, imagine we have a little stack over here. Maybe I'll draw like a pancake. So pancake at the bottom, we have 73. And then we have 74. Okay, then we have 75. Then we have 71. But when do we pop? The condition here was when we found an associate closing bracket. The condition here would be something about, oh, we actually moved the thing. That's so cool. Okay. The condition here would be like when we have a what's it called? Either a higher or lower temperature. I don't know which one. Well, okay, so it's going increasing, and then all of a sudden it decreases. So what do we do here? Do we stop? Or the other option is maybe at this stage 74 we should be doing some kind of popping. Or maybe it's the other way, right? Like 73, 76. Yeah, I don't know. Alright, well it's at 12 minutes. I'm gonna go ahead with that brute force solution. Don't know how the stack. Again, the fact that I know this is a stack, how would I determine this is a stack? I actually don't know, because usually it's like brackets, something to do with brackets, something to do with nested structures, and that's none of this. Or maybe it does and I just don't see it. But what I'll do is I'll just go ahead with that for solution. For I in range 0, length of temperatures. For J in range, length of temperatures. Well, actually, you'd want to start from I plus 1. If I temperatures, we're doing a nested structure, so we start off with I, and then J is like that next, so like we're at 73, and then I is here, and then J is here at 74. And then we want to check if this one, if the first element is less than the second element. And if so, we want to append it to our answer. We want to append J minus I. So that is 1 minus 0, and I think that's correct. And temperature, a boolean for the fact that if we never find a higher temperature, I think that would be what the not statement here. Then this thing would never, like this append would never actually run, so we want to just run with 0, like that. And let's give this a shot. Let's run. Syntax errors. Oh. Oh my. All right, what's going on here? Why are there so many answers? It's because I'm doing a nested structure. Oh. How do I... Okay, hold on. Let me go back to my brute force thing. So 73, you want to jump. 74, you want to jump. 75. And the second you reach this, you can break, right? Maybe that's the problem. Oh shoot. If I solve this, I'll be so surprised. No, I don't think I solved it. Oh, time limit exceeded. Interesting. Okay, yeah, that was the issue. Alright, so we reached the solution. It's just that the time limit exceeded for this one. Now, by looking at this, I still have some time, like 5 minutes, so let's do some analysis. Looking at this, is there an optimal way to go about doing it? To be honest, I don't know. But I will know once I look at this a bit more harder. And this is not the commentary I want to provide to my interviewer. I want to be a bit more knowledgeable, smart. To be honest, staring at the screen is not helping. Now, this is a nested structure. Can a stack? Yeah, like just guessing which data structure will fit in is not like a good practice. Like again, I'm using the fact that this is under the the stacks category to help myself. But if I were to do this in an interview and just not be guessing the data structure correctly, what it demonstrates to the interviewer is that I don't understand my data structures. And so, yeah. Back to the drawing board. How many test cases passed? 36 out of 48. Almost there. Almost there. But, So in this instance, this is 1, that's 1, this is not 1, but this, what is this, does this reveal anything to us? This trajectory from 75 to 76, does it reveal anything about these numbers here? Well, we know that 75, like this number at 76, which will be a j at some point, is greater than I. But all these values are less than the number before. Right? And at this point, they're going to be less than 76. So we know something about this, and that there is a higher temperature along the line. Does that reveal anything to us? Well, this is going to be 1, that's going to be 1, that's going to be 2. But that's, again, going through the same algorithm. It's not doing anything novel. Alright, I'm going to leave it at that. I'm going to watch a NeetCode video. It's 22 minutes in. Good job, though. That was a nice attempt. I think I'm getting a bit better at this. I think I commentated more in this one. Okay. Oh my god, it's like 5. Oh. Okay. I'll keep at it.